IC can be your database solution by bringing together disparate data types in one database, showing multidisciplinary teams, relationships and opportunities that can only come to light when all information is integrated. You could think of IC as the most experienced subsurface team member in a company. They have been involved in each step of well planning, drilling, analysis and interpretation for every well in the database. They have a flawless memory. The structure of an IC database is such that each well will occur only once in the database, ensuring that you're always viewing the most entire and up-to-date version of the data. This figure shows how the database well list can be organised into different projects. This means that if you're working on a particular field and only want to include information pertinent to that particular area, you can focus down the information you're looking at to be more relevant to your study. Then you're not having to sift through irrelevant data from other locations to get to the information you need. Wells can be included in multiple projects or none at all, meaning that if someone in Project A loads data and updates this well, then anyone in Project B also benefits from that updated data. IC has a flexible data structure that allows you to store and organise data as you wish. When you first install IC, you will be offered a suggested set of data tables with data types within. However, this structure is completely flexible. You can add, remove and edit any tables or data types you wish. The idea of this data type, data table structure is somewhat hierarchical. It allows you to group together data types that are relevant and related to one another in such a way that they're much easier to find and you know exactly what data belongs in which table. For example, here I have my lithostratigraphy data table including all of the data types that are part of that lithostratigraphic hierarchy. Another example might be petrographic data, where you've got data from XRF or XRD studies. They're not part of a hierarchy, but each mineral value is related to the other in that it's a component of a whole. Having manual control over the data being imported means you can maintain data integrity regardless of source or purpose. The users of a database can be managed so that only the people who are supposed to be able to change and edit your wells and add data have those permissions. Users that should only be able to view or export from the database can be restricted from changing and modifying your data, therefore protecting the integrity of your dataset from damage. There are many ways to import and export data from your database, including the simple import of LAS and ASCII files. To import LAS files, you can simply pick up your files from your data folder and drop them into the IC workspace to launch the LAS file loader. I can see quickly that these wells aren't yet in my database, so I can create my wells. I'll add them to the project if they're already in the database but not yet included in this current project. This then allows me to match my curves to a suitable mnemonic before importing into my existing database. It takes a couple of seconds to import files, and I can then go to those wells and view the data within seconds of it coming from my flapped LAS file. IC also supports the import of ASCII files, whether that be CSV, text files, .dat files, and this can be in the form of multi-well files or single well files. With multi-well files you can then point to the correct folder to select your files, choose the appropriate columns to match. So in this example I'll be loading to my lithology table with the interpreted lithology data type and matching the columns in the file to the columns in the IC database. I can work through the steps, match my wells to wells already in the database, and add those quickly and easily to my project. So now if I go and view the data in the wells, look under lithology, I can quickly view the data in table format. With this now open, this is an example of a discrete data table. I'm showing the top depth, base depth, and the unit name of my lithology data, along with any audit information such as the date the data was created, what file it came from, and the user that created it. This audit information can be really useful to manage the integrity of your database. If you find that data has changed unexpectedly, you can check the audit trail to see when and by whom that data was changed. If I compare this table to another table for a different sort of data, you'll see that the format of this table is quite different. We've got one depth column and then a column for each of my data types. This is because I've got different styles of data applied to these data types. This is shown quite well in the database manager. So for my lithology data, I've chosen a interval graphic fill with no boundaries, so I'm not using the boundary type. However, from this list you can see we've got a very large variety of data styles you can use. So you'd be hard pressed to find a data file that couldn't be displayed with one of these styles. We cater for very specific types, from your sequence stratigraphy data right down to quite generic styles such as point value or point comment. You'll see each of my lithology and lithostratigraphic data types are managed individually, therefore they've got unique depth values, whereas if I look at my petrographic data, they're managed as a collection because they share depth points. The other difference you'll see is that some of these are filled in and some are not. The filled in icons show that it's an interval data type, and the empty ones show that it's a point data type. IC also allows you to store different interpretations of the same data type. This can be managed from my interpretation manager. You can make an interpretation for specific people or specific groups, and you then give specific users read-only or read-write access to these specific interpretations. Now, viewing this on a data view, if I open up my lithostratigraphy, I'm currently viewing the Katrina interpretation of my group data, whereas I could change this and instead view the default interpretation or alternative ones. And if I view them all at once, you'll see that each of my data units is tagged with an interpretation, showing me who that belongs to or which interpretation that is. This is better seen on a chart where I can display two different interpretations of the same data side by side to enable me to form a comparison with how these two interpretations differ and perhaps why. IC has data links to several other software packages. I'll show you an example with our Patrol link. This relies on having a Patrol project open simultaneously. You can either take data from Patrol or from IC and push it towards the other software. This works simply by selecting the wells you want to transfer. So in this example, we'll take some wells from Patrol. We'll update the information we've already got in our IC database. We can match these wells across to the equivalent in the Patrol project. This data link allows you to transfer any resources, whether that be surfaces, faults, boundaries. We can also take in cross well paths, any picks or intervals that you stored in either IC or Patrol, and any logs that you have in one software that you want to use in the other. Once you've selected all of the data you want to transfer, you just click Patrol to IC, or if you're going the other way, IC to Patrol, and then you'll get a list of results from what is being transferred. So this is a group of wells that I've transferred previously, and if I open those, I can see that I've got well path data for these wells. Some of them might have some TOPS data that I've brought in from Petrel that has exactly the names that they were used in Petrel, and any well path data or via line log data. So here we've got like gamma ray and some porosity data. The other data links we have include Stratabugs, Geolog, OpenSpirit and OpenWorks, along with a new data link with Extreme Connect that allows you to bring in real-time data. Another new feature in IC is the compatibility with IC. We now have a common database link, so we can share wells between IP and IC. This means we can launch one software directly from the other. So I currently have IP open alongside IC. We can launch IP from within IC or IC from within IP. When you decide to share a database between IP and IC, the software where the data originated remains the owner of that data, although it can be viewed and edited in the other software. I'll demonstrate this once we've got IP open to show you that we've got shared wells between the two, and you can see that these wells all originated in IC and these wells all came from IP. They've got that IPD prefix to them, which tells me that they haven't originated within IP. If I look at my data manager, I can see that as well as the original data tables I had in my IC database, I've also got some IP data tables that have this IP set prefix to them. This just tells me that any data in these tables comes from IP. Likewise, in my IP database, if I open up a well I know contains IC data and I look at the parameter sets, I can see that anything with an IC prefix, whether that be lithostratigraphy or engineering data, has this IC prefix. This tells me where the data originates from and gives you a source, like an audit of that data. We have the link between IC and IP so that we can then go and make correlations and maps in IC from data in IP, where you've got so in IC you've got the best tools to build those charts, correlations and maps, whereas you might want to take some of your curve data from IC to do more advanced interpretation, advanced petrophysical interpretation. Another option to bring in more data into IC is using an RPM module. This allows us to incorporate production data that has a time variant to it. So in this example database, I've got some production data that is split by zones, it's split by timestamps, and I've got values for my oil, water and gas for these wells. So if I look at some of this on a chart, one example would be to use a single well chart where we've got a bit of a summary. And in this example, I can set my time period to 3 months, zoom in a little, and set the time to nudge forward through time, so we can see this water oil chart is updating along with the curves in my well stick. You can see these curves are changing colour. Soon we'll start to see trends in the temperature and pressure curves to show how they're varying over time. You're starting to see a bit of a spike in this temperature curve, and we'll see later on that this pie chart will start to expand according to the different levels of fluid that are being produced. So here we've got some more gas being produced as well as oil. The other plots on this chart are cross plots and maps. Another example could be a multi-well chart where we have several wells plotted around a map to show how the whole field is doing over time. So in this example I've got some production plots over my map in the middle, I've got a production grid behind, and then I've got some more detailed line plots surrounding that map. Again, I'm going to set this off at 6-month intervals to nudge forward through time, so you should be able to see some changes when the chart updates, giving different colours in different parts of the map, different wedges in the pie charts, and different plots in the surrounding line graphs. So similar to the previous single well charts with RPM data, the charts are a good way of integrating multiple data types in one canvas to bring together the big picture for that well. As well as well data and log data that can be plotted on a chart and incorporated digitally into the database, we can also add references to your wells or to your project. In this example, I have references that refer to the whole database or the whole project. I have charts I can open within IC, this one showing just a picture of the project structure. You can also choose to link to specific folders. This might be where you've got lots of images or figures related to the wells in this. You can also add well references. If I take a look at one of my wells, I can see I've got references available, and this takes the form of a specific folder. So if I open this one, I can open that folder within IC without having to leave and browse through my whole network or computer. Or I can view the images natively. A really useful feature when you're building a database or taking on a database is the data summaries. These are invaluable in recognizing what data you have in your database and where. In this example, I'm showing you the discrete data summary where you have your wells against all of the data tables. Now these tables can be expanded to show the data types within, and they're all color coded according to which have data in them and which do not. We also have ones for logs, the pink showing where you have logs set as final. We've even got summaries for references to show which wells have those references added. So these are a really good way of managing your data and understanding what is there and what is not. Once you've started loading your data or you importing your data, the utilities within IC can be really helpful. You can use conversion utilities such as picks to intervals, where you can load data with just one depth point, create a rule to convert that into an interval, and then you've got data that has two depth points, so you're building up data from a single start point. This could be intervals to picks, curves to intervals, intervals to curves. We've also got depth shift and core shift options, and a whole list of other data management tools you might need. We also have tools for managing your log curves, so these can be anything from resampling or smoothing a curve to changing its name. To then get some information out of your database, we have the reports. So these can be used to interrogate and interpret the data you've imported. In this example, I'm going to build a log statistics report based on my gamma ray on a certain interval. If I click OK, I can then see the data for all of the wells I selected split into the multiple intervals that were selected. So in this example, we've got your minimum and maximum values in the curve in each of these wells, averages, percentiles, and sum values. The statistics of the data are broken all down into this report that can then be exported and used in your reports or your write-up for your client. I should hope this has given you a flavour of the data management tools in IC.